Alright, so for number 1, we're looking at which feature exists at the point 0, negative 4. So if I look at 0, negative 4, I can see that I have a minimum. Now the question is that minimum going to be a absolute minimum, or is it going to be a relative minimum? So when I look at the graph, I can see that the graph will continue going down in both directions. So it's not the lowest point, so it can't be absolute. So this is going to be a relative minimum. Alright, so for number 2, it asks you for the end behavior. So if they give you the graph, great. If not, just put it into Desmos and you can type it and see the graph there. And just to make sure that everybody is clear on that, if I pull Desmos up and I go to graph this, all I would do is type in y equals, and I would simply put in my equation. So 3 raised to the power of x minus 3x minus 2. And I can hit the little home button up there in the top right corner and you can see the same graph. Now they've got it, oh, forgot my x. I was going to say that does not match. Alright, so we can see that it shows the same values of where it intersects, so you should still have that same option. But again, we're asking about the end. So I asked myself that question. On the left side of my graph, is my graph going up or is it going down? So this one is going down. So when I write this, x is going to negative infinity. Why is it going to negative infinity? Because my x values are going to the left. Y is going down, so that's also going to negative infinity. So let's look for that combination here. So we have x to negative infinity, y to positive. So that's not a true statement. All right, then we have x to negative infinity, y to positive. That's not a true statement. Then we have x to negative, x to negative, x to negative. So we've got 2 options removed. Now let's look for the second one. So now we're on the right side. My right side is going up. So x is going to positive infinity this time, because on the right side, x's are positive on the right side. And then my y values are going up, so those are also going to be positive. So if I look at my answer choice, the only one that's going to match is as x goes to positive, y goes to positive, making my answer C. Alright, so this one says, which of the following intervals does the graph increase? So when I look at my intervals, I'm asking for increasing and decreasing. So I'm going to highlight as I move my graph from left to right. So as I'm coming from the left, I'm decreasing in yellow. And then I'm going to start to increase at that minimum. And then I'm going to start to decrease again at the maximum. Increase again at that minimum. And I'm going to keep increasing to the right side. So the question asks us which interval is increasing. So increasing was in pink. So we're looking for the intervals in pink. Now remember, we're doing x values. So when we look at our x values, we're looking at those values of where it changed direction. So really the maximums and the minimums, those x values of those points. So in the pink, we have this area that was increasing. Actually, let me highlight. That might be a little bit easier to see. So we have this area right here that was increasing. And we have this area right here that was increasing. So we are looking for from -1 to +1. And we're looking from 3, and it's going to keep going to infinity. So we have -1 to +1, and then 3 to infinity, where it was increasing. Alright, so it says, what are all the x-intercepts? So remember, x-intercepts can be called zeros as well. So we're looking for -3, -2, 2, and 3. So we are listing these as points in this one, but remember, you can also list them in set notation, where we can just say x is -3, -2, 2, or 3. Alright, so for the next one, which polynomial has below has an end behavior that is different from the rest? So you're looking for which one is different. So I'm just going to look at my ends and I'm going to identify. So on the left side here, I'm going down. So I'm going to look at all of them. This one is left and down. That's right. This one's left and going down. Alright, this one is on the left and going up. So out of all of these options, D is the one that's different. I can even look at the right side, so right and up. This one's going right and up. And then finally, same thing, right and up. Alright, so what is the y-intercept of this problem? So a couple of options here. One, we can plug in 0 for x. That's a pretty simple one here. So if I have x equals 2x squared plus 4x plus 6, then I'm going to plug in 0 for my x values. And 0 squared is still 0, so those are going to cancel. So y equals the last number, which is 6. And that is a y value, so it's going to be 0, 6. Or I can go to Desmos and I can put in my equation. So y equals 2x squared plus 4x plus 6. And I find where it crosses the y-axis and just click the point. Alright, so range. Remember, range are my y values. And my y values go from bottom to top. So from the bottom, I'm going to kind of show my boundaries here. So we have this is where it starts at the bottom. We have a lot of stuff going on in between here, but there's nothing that's undefined. And then it stops going up at this value of 3. So it goes between the values of -3 and goes up to 3 with brackets because these are both closed dots, which means they're included. So the answer is B. Alright, so it asks us to identify the local max and the local min. So again, I could put that in Desmos if I needed to. Yes, it would take a little bit more effort because there's some fractions here, but I normally, when I'm typing a fraction, I like to go ahead and hit that division symbol, and it creates a fraction template for me. And I would put that in. And then we have plus 3/8. I'm just struggling with this one. X squared plus 2. So just make sure it matches. Obviously, you know, if you're struggling, just make sure that your pieces are in the right spot. So we have a minimum at 0, 2, and we have a maximum at 4, 4. So minimum at 0, 2, which is what we have here. And then we had a maximum at 4, 4. And that would have given me the answer is C. Alright, so for this one, domain, you can use Desmos, or if you want to use your algebraic features that I told you, remember the algebra, doing it by hand, tells me that if I have a square root, then my square root has to be greater than or equal to 0. So I would say that -x plus 2 is greater than or equal to 0. And I'm going to subtract 2 to the other side. Now, here's where I need to be careful. When I divide by that -1, I've got to flip that sign, because we're dividing by negative. So it should be less than or equal to positive 2. So if we're talking about less than, here's 2, and here's less than. So this is going to be -infinity to 2, because we're talking about the less than area. Or I can graph it in Desmos. So y equals square root -x plus 2. And again, we can see that it's coming from -infinity and goes up to 2. Alright, so we have discontinuous or continuous. So it says, classify the function as continuous or classify its discontinuity at x equals -8. So if I go to -8, I can see right here in this area what's going on here. Well, we can see that we obviously have this removable point here. So we're looking at removable discontinuity. All right, so remember that if it's got a jump in between it, so if we're missing some y values, that's going to be jump discontinuity. And infinite discontinuity is when I have two separate pieces that are separated by an asymptote. All right, so this one asked me for the domain. So the domain are my x values, and we're going to read that from left to right. All right, so we're looking at this x value is 0, and it's going to go to that x value of 5. And there's stuff in between here, but everything is defined. So we're going from 0 to 5. So how do we write that in interval notation? Well, this says x is less than 0, less than or equal to, so that's not true, because we're not even talking about the y values. X is less than or equal to 0. So if we're talking about between 0 and 5, we're going to have the correct answer as B. Alright, so range, remember range is y values, and we're going from the bottom to the top. So we're starting at 30, and we're going up to 80. So we're going between 30 and 80. So the interval notation that says that, make sure you pick the one that's got the correct variable, because we're looking for the range. So that's going to be 3. Alright, so we're looking for the negative portion. So determine which interval represents a negative only portion of the graph. So I'm going to highlight, remember when we're talking about intervals, we're talking about x values. So x value to x value. Alright, so the first one is from positive 5 to 3. Or excuse me, that should say negative 5. So when you see it, it'll say negative 5. So negative 5 to positive 3. So all the way to 3. Now the key here is that this says negative only portion. So yes, there are some negative sections in here because it's below the x-axis, but that's not the only. There's also positive, so we're going to get rid of that one. Alright, so let's look at the next one. Alright, so we have negative 4 to negative 2. So negative 4 to negative 2. That is negative only, so that's the correct answer. Alright, and define the domain algebraically for the last one. Whoops. It's so we have a denominator and we have a square root. So remember, when we have a denominator and a square root, that means that it has to be greater than 0. It can't equal 0 because it's in the denominator. So we're going to say that x minus 4 is greater than 0. So if we add 4 to both sides, x has to be greater than 4. So number line 4, it can't equal 4, but it's going to be greater. So we're going to go 4 to infinity, making the correct answer B, or the second one. Now, I can look at this and verify in Desmos. I know I asked you to do it algebraically, but I'm definitely okay with you verifying that you did it correctly. So when I look at this, I can see that, I have this vertical asymptote here. It's approaching 4, but it's never going to actually cross over 4. And then it's going to keep going to positive infinity, which is correct. All right.